All right, guys. All right, we're gonna start. I'm gonna start at the top and work my way down the figure. So I'm gonna start right over here with this half cylinder. It's sitting right on top of over there. It's sitting right on top of the that cylinder. So it has a radius. So let's see, it's a half cylinder. Has a radius equal to 5 feet. So that means that the area normally, surface area for a cylinder, sorry, not cylinder, sphere. There we go. That's that cap. That's 4 pi r squared. So 4 pi times 25, or 100 pi, for 314. Now, we only want half of that because it's not a full sphere, it's just a half that sits on top. So I'm going to divide that by 2 to make it a half, which gives me 157 square feet. So that's that first cap. Boom. Now I'm going to hop over and do the...
Wait, did you just do the sphere?
Yep. Let's do the cone over there. Now the thing about the cone is that it's just the lateral area of it, no base. And the lateral area of a cone, we said, was going to be pi times r times the slant. Now I'm a little stuck because I don't have the slant, I just have the height of 10. So here's a right triangle with 10 here and 5 here. If I do the Pythagorean theorem, I'm taking the square root of 125. So Pythagorean theorem tells me that this length is 11.2. And that'll be the slant. Nah, you could. I would say yes, except for the fact that I'm already dealing with pi. So I'm already going to be dealing with some decimals. Although this is a pretty big figure, nearest square foot's probably a safe way to round. But I like to do my rounding at the very end of a problem, just to be sure. So let's see, that's going to put me at, let's see, 3.14 times 5 times 11.2, 175.8 square feet. All right, so I got that done. I've got these 2 tubes to deal with. That's these guys. So I'm working my way down. So the towers are tubes. And they're going to have a surface area equal to the circumference, or the perimeter, times the height. So let's see, the circumference is going to be 2 pi r. 2 pi times the radius. So 2 times pi times 5 times 10. That puts me at, let's see, 10 times 10 is 100, or 314 square feet. Now, I've got 2 of those. So there are 2 314ths. All I gotta do now is the box at the bottom. Everybody's pretty straightforward. Let's do we're going to do this piece up here on top last. That'll be the last thing I figure out. That guy right there. We'll do him after everybody else. I've got this lateral wraparound area. So the lateral area of the box. Let's see, 40, 50, 40, 90, 50, 100. So it's 100 feet around times 20 feet tall, 2,000 square feet going around the box. The base of the box is 40 by 10, or 400. Last question now is, how do I get the top piece? The piece that sits on the very top of this.
400 and subtract the 2 circles from 400.
Yeah, I take 400 square feet. And from that, I'm going to subtract off the two cut out circles. So twice pi r squared. So that means I'm going to take that 400 on the top and subtract off, let's see, 25, 50 pi. 50 pi is 175. Oh, I'm sorry, 157. That puts me at 243. So all I got to do now is add up the roof of the castle, the base of the castle, the walls of the castle, the two towers, the cone, and the cylinder. And that'll give you the overall surface area for that composite. It's kind of a complicated composite to start with, but what I like about it is it makes you guys break it into pieces. And once you see it, as you take the three-dimensional object, and you just look at it as things you can find, tubes, spheres, cones, boxes, or things that have been cut out from those, it's not that bad.